In this question, we've been told that in a shopping survey, a random sample of 104 teenagers were asked how many hours, to the nearest hour, they spend shopping in the last month. The results are summarized in the table that's given to us, and we're asked to use linear interpolation to estimate the median and also to estimate the interquartile range. So the first thing we should notice is that we have some intervals, but there are gaps in between the end of one interval and the beginning of the next. The first interval ends on 5, the next one starts on 6. Where should you place 5.2? Where should you place 5.7? Because of these gaps, we need to use bounds. We need to close the gaps. We need to find the lower bound of the lower limit and the upper bound of the upper limit, and make sure we use these values for any work that we do within this question. Linear interpolation is going to need a cumulative frequency, so we'll add the cumulative frequency as a column over here. And since we know there was a total of 104, so the sample size was 104, we know that the cumulative frequency has been done correctly as well. So that's a little sense check that we should always be able to use. Okay, let's locate the position of the median. The median is going to be the halfway point. So let's take 104 and we'll divide it by 2. That gives us 52. The median is going to be in the 52nd position. Now, which interval contains the 52nd position? It will be the first interval that has a cumulative frequency above 52. And I've highlighted that here. Okay, let's quickly get our interpolation diagram. We know that our value is in between the 36th and the 54th value is the 52nd. And this interval ranges from 7.5 to 10.5. From here, we should be able to set up a fraction equation to solve for Q2. Q2 minus 7.5 over 10.5 minus 7.5 equals 52 minus 36 over 54 minus 36. Simplifying and rearranging. So I haven't actually touched the calculator probably until this last point here. And just putting all of this into the calculator, 10.167. That's my median. We've also been asked to find the interquartile range. To find the interquartile range, we're going to need the lower quartile and the upper quartile, Q1 and Q3. The position of Q1 is going to be n over 4, so that's going to be the 26th position. We need the interval whose cumulative frequency is the first one to go above 26. So here we go, 5.5 to 7.5. Okay, here's the diagram. We know that we're in between the 20th and the 36th value, 5.5 to 7.5, and we'll set up just the same thing. A fraction equation that demonstrates the thick part of the diagram over the entire length, first using the hours and then using the cumulative frequencies. Okay, because of proportionality, this gives us an equation that helps us to find the exact value of Q1. So once again, just some simplifying in my head, rearranging, substituting into the calculator, we get 6.25. And finally, let's do that for the upper quartile as well. It's going to be 3 times n over 4. So 3 times 104 divided by 4. That's the 78th value. Okay, which interval are we looking for? The first one whose cumulative frequency goes above 78. And that's right here. 54, 79, in between 10.5 and 15.5, the same sort of equation. The thick part of this interval divided by the entire length, using the hours, using the cumulative frequency, rearrange, and solve. So Q1 equals 6.25, Q3 equals 15.3. The interquartile range is what we were asked for. This is going to be the difference between these two quartiles, 15.3 minus 6.25. And that gets us 9.05 as our interquartile range.